Welcome to a practical setup lesson on setting up a UV-based Python project. Let us build your first project. In the previous lesson, you set up Versus code with the Python extension. Now we create a proper Python project using UV, the modern Python package manager. This lesson shows you the directory structure, the commands, and the workflow you will use in every lesson from A.9 onwards. By the end, you have a project template that handles dependencies, virtual environments, and running code, all with a few simple commands. The template for every future lesson. Why are we using UV? It is the modern way to manage Python projects. One tool handles everything: project creation, dependency installation, virtual environments, and even Python version management. It is written in Rust, making it much faster than pip. It creates a pyproject.toml file, the modern standard for Python project metadata. It creates a .ven virtual environment automatically, no manual activation needed. And it creates a lock file, uv.lock, that ensures reproducible builds. You already used UV in the IPython lessons when you ran UV tool install IPython. Now we use it for full projects. One tool, everything managed. Every project needs structure. Today we build the template you will use for every lesson from A.9 onwards. Structure before content. Step 1. Create the project. Type UV in it followed by a project name, for example, my_project. UV does several things at once. It creates the project folder. It creates a .ven virtual environment inside it. It writes a pyproject.toml with project metadata. It creates a main.py with a simple hello world. It creates a readme. And it creates a .python version file. One command, and the entire project skeleton is ready. One command, full skeleton. Here is the directory structure UV creates. The .ven folder holds the virtual environment, your isolated Python with installed packages. You rarely touch it directly. The .python version file pins which Python version this project uses. Main.py is a simple hello world script, your starting point. Pyproject.toml is the heart of the project. It holds the project name, dependencies, and configuration. uv.lock is the lock file. It records the exact version of every package, so anyone can reproduce your environment exactly. And readme.md is for documentation. Memorize this structure. A virtual environment is a private Python just for this project. UV creates and manages it automatically. Each project is a bubble. Let us look inside pyproject.toml. The project section has a name, a version, the required Python version, and a dependencies list. When you first create the project, dependencies is empty. After you run UV add requests, it becomes a list with requests in it. After you run UV add --dev pytest, a new section appears for development dependencies, packages you only need for testing, not for running the project. This file is the single source of truth for what your project needs. The heart of the project. Step 2. Add dependencies. Navigate into your project folder and run UV add followed by the package name. For example, UV add requests. UV downloads and installs requests into the .venv. It adds requests to the dependencies list in pyproject.toml. And it updates the lock file with the exact versions installed, including requests and all its dependencies. One command, 3 things done. You never need to manually activate a venv or run pip install. One command, 3 things done. There are 2 kinds of dependencies. Production dependencies, packages your project needs to run, like requests and Boto3. And development dependencies, packages you need to develop and test, like pytest and rough. Use UV add for production deps and UV add --dev for dev deps. UV keeps them separate in pyproject.toml, so when you deploy your project to production, dev dependencies are not installed. This keeps your production environment lean. Keep production lean. Let us understand the .ven folder. It is a virtual environment, a complete, isolated Python installation just for this project. When you install requests with UV add, it goes into the .venv, not into your system Python. This means project A can have requests version 2 while project B has requests version 3, no conflicts. Each project is a bubble. UV creates and manages the bubble automatically. You never activate or deactivate it manually, UV run does it for you. Never activate manually. Step 3, run your code. Edit main.py, import requests, fetch some data, print a result. Then run it with UV run main.py. The UV run command does 3 things automatically. It activates the .venv. It makes all your installed dependencies available. And it runs your script. When the script finishes, the venv is deactivated. You never type activate or deactivate. You never worry about which Python is running. UV handles all of it. Just prepend UV run. Here are the UV commands you will use daily. UV init creates a new project. UV add installs a dependency. UV add -- dev installs a development dependency. UV run executes a script in the project venv. UV run pytest runs your tests. UV sync installs all dependencies listed in the lock file. This is what someone else runs when they get your project. UV remove removes a dependency. And UV lock regenerates the lock file. That is 8 commands. Everything else is automatic. 8 commands, daily workflow. For bigger projects, which is what we build from A.9 onwards, we use a slightly different structure called the SRC layout. Your Python code lives inside src/my_project, with an init.py file that makes it a proper package. Tests live in a separate tests folder. This separation is important. It lets you install your own package and import it cleanly, and it keeps tests separate from production code. Every A.9 lesson will show this structure in its project setup slides. The structure from A.9 onwards. By the end of this lesson, you have a project template you can copy for every future lesson. Copy this for every project. Here is the full workflow from zero to running project. 1. Create the project with UV init. 2. Add dependencies with UV add. 3. Write your code in the source files. 4. Run it with UV run python-m. 5. Test it with UV run pytest. 6. Open it in Versus Code with code. 6 commands. That is the entire workflow for any project in this course. Every lesson from A.9 onwards starts with these 6 steps shown as project setup slides. 6 steps, 0 to running. If you remember 3 things from this lesson, remember these. 1. UV init creates the project and the virtual environment automatically. 2. UV add installs dependencies into that virtual environment. 3. UV run executes your code using that virtual environment. Everything else is automatic. You never manually activate or deactivate venvs. pyproject.toml is the single source of truth for what your project depends on. Change it, add a dependency, run the code. That is the workflow. 3 ideas. That is all. Here is the checklist. UV init creates a project with a .venv. UV add installs a package and updates pyproject.toml. UV run executes code using the project venv. Versus Code detects the .venv and uses it automatically. pyproject.toml lists your dependencies. And UV.lock pins exact versions for reproducibility. If all 6 items make sense, you are ready for A.9. 6 items. All clear. Ready. What comes next? A.9 begins. Every lesson from now on is a real project. You create it with UV init, add dependencies with UV add, write code in Versus Code, run it with UV run, and test it with UV run pytest. The project setup slides at the start of each lesson show you the directory structure, the UV commands, and how to run the code. This is the workflow of a real Python developer. The foundation is complete. Real work begins. Real projects. Real code. Your project template is ready. A.9 begins with real projects. Template ready. A.9 next.